All right, let's dive into one of the most wonderfully mind-bending ideas in all of mathematics. We're going to explore a hotel that completely breaks all the rules of common sense, a place where the word full doesn't mean what you think it means at all. So get this. Imagine a hotel with an infinite number of rooms. Room 1, room 2, room 3, and so on forever. And here's the kicker. Every single one of those rooms is already occupied. The no vacancy sign is brightly lit. So how in the world could they possibly make room for even one more person? It seems completely impossible, right? Well, this famous puzzle is called Hilbert's Grand Hotel. It was cooked up by the brilliant mathematician David Hilbert. And its whole purpose isn't to be a realistic travel destination, but to force us to confront a concept our brains just aren't really built for: infinity. It shows us that infinity isn't just a very, very big number. It's a completely different idea with its own bizarre and fascinating set of rules. So let's set the scene. Our infinite hotel is open for business, but there's a problem. Every single room is occupied. There is not one single empty bed to be found. A weary traveler walks up to the front desk and asks for a room for the night. The receptionist, with this unnervingly calm smile, just says, "I'm terribly sorry, but we are completely full." For our traveler, the situation looks pretty hopeless. But this is no ordinary hotel, and the manager has a plan. What's absolutely impossible in our finite world becomes surprisingly simple when you're dealing with the strange logic of infinity. Here's the manager's incredibly elegant solution. They get on the hotel's intercom system and make a very simple request. Would every guest please move to the room number that is one higher than your current one? So the guest in room 1 moves to room 2. The guest in room 2 moves to room 3. And this giant chain reaction continues forever. And because every single guest has just shifted one room down the line, what happened to room 1? It's now completely empty and totally ready for our new arrival. Problem solved. Even though the hotel was full just moments before, it made space for one more. Okay, that was a pretty neat trick, but let's up the ante. A bus pulls up outside the hotel. This isn't just any bus. It's an infinitely long bus carrying an infinite number of new guests, and they all need a room. Surely now the hotel is in serious trouble, right? Making room for one person was one thing. But making space for an infinite number of people inside an already full infinity, that seems like it should just break logic itself. But the manager isn't even breaking a sweat. They just need a slightly cleverer plan. So the manager gets back on the intercom with a new announcement. This time the request is this: every guest must now move to the room number that is double their current number. So the guest in room 1 moves to room 2. The guest in room 2 moves to room 4. The guest in room 3 moves to room 6, and so on. Now think about what this does. By moving every guest from their room N to a new room, 2N, all of the original guests are now only occupying the even-numbered rooms. This means that all of the odd-numbered rooms, 1, 3, 5, 7, and on forever, are now empty. And just like that, we have an infinite number of empty rooms for our infinite number of new guests. Mind-blowing. I know, this feels completely absurd. It clashes with everything we know from our everyday lives. So why on earth does this logic actually work? Let's break down the fundamental difference in how we have to think about this. See, in our world, a full box is a full box. You can't add anything more to it. But in the world of infinity, a full set is more like a perfectly organized collection that can always be, reorganized. Infinity plus 1 is still infinity. Infinity plus another infinity is still infinity. It's not a number you can ever reach. It's a concept that completely stretches our imagination. The specific kind of infinity we're talking about here actually has a name. It's called a countable infinity. And this idea, which was really pioneered by mathematician George Cantor, just means an infinite set where you can list out all the elements in a sequence, like the rooms in our hotel. Incredibly, Cantor even showed that some infinities are actually bigger than others, but that's a whole other explainer for another day. So, okay, this is more than just a quirky brain teaser. Thinking about these strange, counterintuitive properties of infinity actually has some pretty serious real-world applications in some of the most advanced fields of science. In mathematics, it's literally the bedrock of a field called set theory. In computer science, Algorithms that have to deal with massive, streaming data sets, like an endless flow of information, they rely on principles that are really similar to Hilbert's hotel. And in physics, our theories about the infinitely dense center of a black hole or the endless expansion of the universe force us to grapple with these exact same concepts. So, the Grand Hotel paradox really shows us that our intuition, which was shaped by a finite world, can fail us in the most spectacular ways when we look at the true nature of reality. It leaves us with a pretty fascinating question. If something as fundamental as full can be so wrong, what other mind-bending truths about our universe are just out there, waiting for us to ask the right questions?